Our next presentation for this morning's session is entitled Peanut Response and Weed Control Following Norflurazon Applied Pre-emergence and at Crack. And our speaker is Delaney Foster.
Hello, can you hear me, Dr. Camerite?
Absolutely, loud and clear.
Awesome, so I'm sharing my screen with you. I'm assuming it's working.
Yes.
All right, great. So yeah, my name's Delaney Foster. I'm a graduate student in the Plant and Soil Science Department at Texas Tech, and I'm really excited to talk to you guys about peanut response and weed control following Norflurazon applied pre-emergence and at crack. A little bit of an introduction to peanut production in Texas. Texas is the second largest peanut growing state in the nation, so peanuts are a huge cash crop for our Texas growers. Just last year, Texas produced 225 million kilograms on 67,000 hectares, worth nearly $145 million. The map on your right shows peanut production by county in 2019 for the United States, and I've highlighted Gaines County, Texas in West Texas. That's the region with the dark green spot kind of in the panhandle. Gaines County is the #1 peanut producing county in the nation, according to the 2012 USDA Census of Agriculture. Over a third of Texas peanut hectares reside in Gaines County, with 40% of total kilograms of peanuts produced by Texas growers being harvested from Gaines County. So herbicides are a big input for our West Texas peanut growers, and early season herbicides are extremely important. The typical West Texas peanut herbicide program would look something like ethylfluralin or another yellow applied pre-plant incorporated, followed by a pre-emergence application of a herbicide like imazethapyr, diclosulam, flumioxazin, acetochlor, S-metolachlor, or dimethatamide. Now these pre-emergence herbicides reside in 3 different WSSA group numbers, or WSSA herbicide modes of action, and those are group 2, 14, and 15 herbicides. But there is another group of herbicide modes of action that are labeled for use in peanuts that aren't commonly used, and those are the carotenoid biosynthesis inhibitors. So carotenoid biosynthesis inhibitors block the production of new carotenoids at one of the various enzymes along the carotenoid biosynthetic pathway. One of these carotenoid biosynthetic inhibitors is Norflurazon, which is a WSSA Group 12 herbicide, and it inhibits the carotenoid biosynthesis at the phytoene desaturase enzyme step. Just some of the literature in 2008, Everman et al. Observed that the critical weed-free period for peanuts to avoid significant yield loss was the first 7 weeks after planting. And this proves that those early season herbicides are really important to our growers. Palmer amaranth is the second most common and troublesome weed in peanut production, according to the 2019 Survey of Most Common and Troublesome Weeds conducted by the WSSA. And Burke et al. Suggests that Palmer amaranth biomass is inversely related to peanut yield. And finally, at a rate of 1.75 kilograms per hectare, peanut foliar chlorosis of up to 23% has been observed with Norflurazon applied pre-emergence, but that peanut injury is no longer evident late season. According to the Norflurazon label, temporary whitening of the peanut leaves may occur. If the peanut's not stressed by adverse environmental factors or diseases, this whitening generally dissipates between 4 and 6 weeks after planting or application. So our objectives for 2019 and 2020 were to examine the response of Georgia 09B runner peanut to Norflurazon applied pre-emergence or at crack, and as well as to determine the efficacy of Norflurazon applied pre-plant incorporated or pre-emergence in a herbicide system. Our hypotheses were that little or no crop response would be observed when utilizing Norflurazon pre-emergence or at crack, and that if integrated as a component of a season-long weed management program, Norflurazon could diversify peanut production systems and help slow the spread of weeds resistant to our other herbicide groups that are commonly used. For our materials and methods, all herbicide applications were made using a CO2 pressurized backpack sprayer at a ground speed of either 3.2 or 4.8 kilometers per hour, a carrier volume of 140 or 187 liters per hectare using flat fan 11002 nozzles. Wide by 7.6 meters long, and we used a randomized complete block experimental design with 4 replications. Data were analyzed by SAS version 9.4 using PROC-Glymix for mean separation. For our crop response trials, we had 2 locations. The first is in Seminole, Texas, which is in Gaines County, the location in West Texas that I pointed out earlier. There, the pre-emergence application was made on May 1st and the APRES application was made on May 12th. And our second location was in Yoakum, Texas, which is in South Texas. The pre-emergence application was made on June 26th and the APRES application was made on July 1st. We did have a weed management trial that had 1 location in Yoakum, Texas, and the application timings were pre-plant incorporated or pre-emergence, both made on June 24th, 2019. On to the treatments for our crop response trial. These were pretty simple. It included a non-treated control and then 0.44 kilograms per hectare of Norflurazon. This is the labeled rate for all states west of the Mississippi River. And then we did a 2x rate, which is 0.88 kilograms per hectare of Norflurazon. Both of those rates we applied either pre-emergence or at crack. Treatments for the weed management trial included a non-treated control. This included a labeled rate of 0.44 kilograms per hectare of Norflurazon applied PPI or pre-emergence. The 2x rate of Norflurazon applied either PPI or pre-emergence, and then both of those rates of Norflurazon applied pre-emergence as part of a system with either pendimethalin or ethylfluralin. So right on into our results and discussion of the crop response trials. I'll go ahead and set up the graph because all graphs in my presentation will follow a similar format, having treatments along the x-axis and in this case percent visual injury along the y-axis. The p-value will always be located in the bottom left-hand corner. So looking at peanut injury 30 days after planting in Seminole, Texas, significant injury was observed at the higher rate of Norflurazon applied pre-emergence and at crack. By 42 days after planting, only the high rate of Norflurazon applied pre-emergence significantly injured peanuts compared to other treatments. These photos are representative of a little bit of the symptomology that we observed at that high rate of Norflurazon applied pre-emergence 42 days after planting. We see a little bit of bleaching towards the center of the leaflets with chlorotic symptoms down the veins. But this is that same plot 60 days after planting, so 18 days later with the high rate of Norflurazon applied pre-emergence, and you see no symptoms by 60 days after planting. This is evident by peanut yield that we observed in Seminole, Texas, shown in kilograms per hectare along the y-axis. Peanut yields in Seminole were similar to the non-treated weed-free control despite early season injury. So moving on to peanut injury in Yoakum, Texas. At 14 days after planting, the most injurious treatment was the high rate of Norflurazon applied at crack, followed by the labeled rate applied at crack. However, pre-emergence applications provided less than 1% injury in Yoakum. 21 days after planting, the trend continues. However, peanut injury did decrease compared to a week earlier. Just as in Seminole, peanut yields in Yoakum were similar to the non-treated weed-free control shown in this graph in kilograms per hectare along the y-axis. So moving right along into the weed management trial. Weed control was rated by species, so I'll begin with Palmer amaranth control, commonly known as pigweed. So this graph has treatments along the x-axis and in this case percent Palmer amaranth control along the y. Again, p-values are located in the bottom left-hand corner. So at 14 days after planting, all herbicide treatments controlled Palmer amaranth greater than 97%. By 30 days after planting, Norflurazon applied alone was not as effective as controlling Palmer amaranth as Norflurazon applied in combination with either pendimethalin or ethylfluralin. This trend continues 60 days after planting, where Norflurazon used in combination with another herbicide still provides excellent control of Palmer amaranth 2 months into the season. However, Norflurazon applied alone does not. Moving on to our next weed species, which is Texas millet. Norflurazon does have its strengths, and those strengths are more of our broadleaf weeds, so it makes sense that Norflurazon applied alone isn't quite as effective at controlling Texas millet compared to being used with one of our yellow herbicides, pendimethalin or ethylfluralin, and those have their strengths in the grassy weed species. So by 30 days after planting, the labeled rate of Norflurazon applied either pre-emergence or pre-plant incorporated provided unacceptable control of Texas millet, while other treatments are still holding strong. And by 60 days after planting, the trend still continues, which shows that Norflurazon applied at its labeled rate really needs a partner in order to be effective at controlling those grassy weed species like Texas millet. Our third and final weed species is smell melon. So looking at smell melon control 14 days after planting, all treatments controlled smell melon greater than 89%. By 30 days after planting, Norflurazon applied alone was not as effective as when used in combination with pendimethalin or ethylfluralin. And finally, by 60 days after planting, this trend still continues where Norflurazon really needs a partner in order to be effective at controlling smell melon. So just kind of some summary and conclusions for our crop response trials at Seminole peanut injury following Norflurazon at the 2x labeled rate, which is 0.88 kilograms of AI per hectare, applied either at crack or pre-emergence was greatest 30 days after planting. While at Yoakum, herbicide injury following Norflurazon at crack was greatest 14 days after planting at the high rate, while injury following Norflurazon pre never exceeded 1%. However, at both locations, no peanut injury was observed by 60 days after planting, and peanut yield was similar to the non-treated weed-free control. For the weed management trial, Palmer amaranth was controlled greater than 90% when Norflurazon was applied pre-emergence alone, but was best when Norflurazon was used in combination with either pendimethalin or ethylfluralin. Norflurazon alone was up to 40% more effective at controlling Texas millet when applied pre rather than PPI. However, the greatest season-long Texas millet control was achieved when using ethylfluralin PPI followed by Norflurazon applied pre-emergence. Treatments that included pendimethalin or ethylfluralin were more effective at controlling smell melon than Norflurazon alone. So the practical implications of the study are that when used at the labeled rate of 0.44 kilograms of AI per hectare, Norflurazon has the potential to be an effective component of a season-long weed management program in peanut production with no adverse effects on yield. Therefore, we fail to reject both of our hypotheses. Future research should include replicating crop response and weed management trials in 2020, which we are doing, and to evaluate the use of other herbicide modes of action that aren't as commonly used in peanut production, but could help slow the spread of herbicide-resistant weeds. With that, I would like to thank the Texas Peanut Producers Board for funding, the Texas Tech Weed Science Team for all of their technical support, and peanut producer Chuck Rowland in Gaines County for use of his production fields both last year and this year for our peanut trials. Here's my literature cited, and I'd be happy to answer any of your questions.
Thank you. Very nice presentation. We have one question to start off with, and the question is, can you expand on the methodology used for mean separation? Proxemics is not a post hoc test.
Sure, so the question was that I expand on the methodology used for data analysis. I could tell you what I did. So what I did was I took each weed species, and they had a rating days after planting. So it could have been 14, 28, 42 days after planting, we'll say. And I took those and I did a mean separation test with Proxemics using Tukey's HSD.
Okay. All right, the second question from Dr. Barry Tillman. Have Texas growers observed Palmer with resistance to Cadre or other herbicides?
Wow, that's a good question. The question was, have Texas growers observed Palmer amaranth that are resistant to Cadre? And if I remember correctly, Cadre is an ALS inhibitor. An ALS-resistant Palmer amaranth is pretty widespread across the United States. I don't actually know if West Texas growers are battling ALS resistant Palmer amaranth, but I do know that it is widespread across the United States, so the possibility is pretty high.
Okay. All right. Thank you. And that's the questions we have. Thank you for your presentation.
Thank you.